Sorting is one of the most important algorithms. It is widely used in various areas of programming. So today let's talk about the different flavor of sorting that STL provides. The first thing to keep in mind is sorting algorithm requires random access iterators. So that limits our option of containers to vector, deck, container array, and native array. List and unordered container cannot be sorted. Associative container doesn't need sort anyway. Here I have a vector that contains a bunch of integers, and then I call the function sort on the entire vector. Since I didn't provide a comparison function, it will use the default comparison function, which is operator less than. So the vector will be sorted into ascending order. Now suppose I want to sort the vector into a different order. I want to sort them according to the value of the last digit. So I define a function called lsbless, which takes two parameters of integer and compare the last digit of the two integers. Then I sort the vector using lsbless, and the vector will be sorted like this. Sorting is nice, but sometimes we don't need to sort everything completely. For example, I want to find top 5 students according to their test scores. I don't care about the rest of the students. So I don't want to waste time sorting all the students. For that, I can use partial sort. I can call partial sort vec.begin, vec.begin plus 5, vec.end, and I provide the comparison function of greater int. And the top 5 students will be sorted in the front of the vector, and the rest of the vector is unsorted. One thing to note is the greater int is a functor, so I need to default construct it into a function. If I don't provide a comparison function and I just call partial sort like this, then it is the bottom 5 students that will be sorted in the front of the vector. Problem number 2. Suppose I want to find top 5 students according to their score, but I don't care about their order. Say I want to pick 5 students to attend a contest, and I don't care who is the best among the 5. For that, I can use nth element. The interface of nth element is same as partial sort. vec.begin, vec.begin plus 5, vec.end, and greater int. As a result, top 5 students are moved to the front of the vector, but they are not sorted. Problem number 3. Now I want to move the students whose score is less than 10 to the front, because they really need to spend more time on their study. For that, I can use partition. And I also need a function called less than 10, which tests if an integer is less than 10. Then I call partition vec.begin, vec.end less than 10. This will separate the vector into 2 groups. The first group contains the numbers that's less than 10, and the second group contains the rest. And neither group is sorted. There's a variation of the partition function called stable partition, which does the same thing, but in addition, it preserves the original order of the items. So 987 is still in the same order in the original vector, which is 987. And same thing for the second group. Now let's look at the heap algorithms. Heap has 2 properties. Number 1, the first element is always the largest. Number 2, add remove takes logarithmic time. If you remember, one of the container adapter called priority queue also had the property of first element is always the largest. Heap algorithms are often used to implement priority queue. The function makeHeap will create a new heap on the target container. So this will convert a vec into a heap, like this. The first element is the largest. Now I want to remove the largest element in the heap. For that, I need to use popHeap function. popHeap does two things. Number one, it swaps the first element vec 0 with the last element. So in this case, it will swap 90 with 1. Number two, it heapify from vec.begin to vec.end minus 1. So it will heapify this portion of the vector and leave the last item alone. So 1 is moved from beginning to a new location. Then I call popBack. It will remove the last item, the largest one. As a result, I have removed the largest item from the original heap and then create a new heap. Now I want to add a new element 100 into the heap. First, I push back 100 at the end of the vector. Then I call function pushHeap to heapify the last item in vec, which is 100. Since 100 happened to be the largest item in vec, it is moved from the end to the beginning. If the item inserted is not the largest, it will be inserted somewhere in the middle. Heap can also be used for sorting, and the function to use is sortHeap. What's different from the other sort algorithms is sortHeap can only work on a heap. So vec has to be heapified first with the makeHeap function, and the vector will be sorted. So these are the 4 heap algorithms: sortHeap, makeHeap, pushHeap, and popHeap. That's all for today. Thank you for watching. Feel free to subscribe to my channel so when I post a new video, you will be updated. Or you can go to my channel's homepage and see what I'm offering today. Bye bye.